Let us continue the presentation of CSEC Multiple Choice Practice Paper 5 with Part C. Another 15 problems. These will take us from number 31 to number 45. If A is equal to 3 and AB is equal to 6, then A plus B all squared minus A squared minus B squared is equal to, there we have A plus B all squared. In the expression given that we have right here, probably the part that requires the greatest consideration. Candidates who are familiar with the perfect square of a binomial, that is, knows that its expansion has the squares of the first and the second terms that are inside of the brackets. So we have A plus B all squared. We know that the expansion of the perfect square will have A squared and B squared. There we have them. A middle term, so it has another thing. It has a middle term that is equal to 2 times the first term times the second term, that is the terms that are inside of the bracket. So we have a middle term that is equal to 2 times A times B, that we have right here, 2 multiplied by A multiplied by B, which is 2AB. Those that are familiar with the perfect square, they know that the perfect square of a binomial will have the square of each of the terms that we have inside of the bracket, which are A and B. We know that we will have A squared and we will have B squared. We also know that in the expansion of the perfect square, there is a middle term that is equal to 2 times the first times the second. That is, this one which is the first and this one which is the second. So it will be 2 multiplied by A multiplied by B, 2AB, and we have the 2 squares right there. Therefore, what do we have here? If we take away A squared and B squared from the perfect square, this is identically equal to subtracting them from the right hand side of the expression. We have A plus B all squared minus A squared minus B squared. But A plus B all squared is equal to A squared plus 2AB plus B squared. So subtracting A squared and B squared from A plus B all squared is equivalent to subtracting A squared from A squared plus 2AB plus B squared, and also subtracting B squared. So we have the expression that we have here that looks a little bit cumbersome, but if we take a close look at it, we have this expression here, and we are subtracting A squared minus B squared from both sides. So let's see. Notice, I think it will be a little bit easier for you to understand if you take a look at what we have highlighted right here. We have A plus B all squared right there, and we have the expansion of it, which is on the right hand side, A squared plus 2AB plus B squared. And that is what we have here. So the two expressions that we have here are equal to each other. And what we are doing is subtracting A squared and B squared from both of them, because the resulting expression will be the same. Therefore, let us see what the result will be. we will have the expression that says that a plus b all squared minus a squared minus b squared, which is what we have right here, is actually equal to 2ab. So a squared plus 2ab plus b squared, if we subtract a squared and b squared, all that we have is 2ab remaining. A squared and b squared are eliminated from the right hand side, as we have seen, by their additive inverses. We only need to find the value of 2ab. Let us find the value of 2ab. According to what we have in the statement of the problem, ab is equal to 6. Multiplying both sides by 2, so we say 2 times ab must be equal to 2 times 6. We have 2ab is equal to 12. The correct answer is option C. All that we have here is 2ab, and we know that ab is 6. 2ab is equal to 12. I have always stressed the importance of students to be familiar with the perfect square. This is just one occasion on which such familiarity would have proven to be of benefit. Here we will take a look at the entire process of expanding the perfect square. Squaring a number is the same as multiplying it by itself, and also squaring an expression is the same as multiplying that expression by itself. Therefore, a plus b all squared is equal to a plus b multiplied by a plus b. There's no difficulty in that. A multiplied by a is equal to a squared. A multiplied by b is equal to ab. B multiplied by a is equal to ba, and of course ba is the same as ab, and finally b multiplied by b is equal to b squared. We have shown that in expanding these brackets we use the first and multiply by each of the terms in the second brackets. Then we take b and we do the same. Multiply b by each of the terms in the second pair of brackets. The two middle terms are like terms and are added together, and that will give one term. ab plus ab will give 2ab. Therefore, we see that if we expand a plus b all squared, the result is actually a squared plus 2ab plus b squared. Both sides are equal. Therefore, subtracting a squared and b squared from a plus b all squared is the same as subtracting a squared and b squared from a squared plus 2ab plus b squared. Let us give consideration to the right hand side. We'll take a look at the right hand side, and what do we know? Now we will subtract a squared and b squared from that right hand side. All that will remain is 2ab with the a squared and b squared combining with their additive inverses, resulting in 0, they are eliminated from the expression. Take another look at the statement of the problem. If a is equal to 3 and ab is equal to 6, then a plus b all squared minus a squared minus b squared is equal to. The result is 2ab and ab is equal to 6. The correct answer has to be 2 multiplied by 6 is equal to 12. This was determined without considering that a is equal to 3. However, some candidates may have used the fact that a is equal to 3 in solving the problem. We will take a look at that and compare the two approaches. Some candidates may find it easy to see that if a is equal to 3 and ab is equal to 6, then b is equal to 2. However, let us take a look at it. We have ab is equal to 6. A is equal to 3, so let us replace a with 3. What do we have? 3b is equal to 6. This is one of the simplest of linear equations and may be solved to give b is equal to 2. A plus b all squared minus a squared minus b squared, that is our expression. We have the values of a, which is 3, and b, which is equal to 2. And may substitute them into the expression. Let us substitute them into the expression. We know that a is equal to 3 and b is equal to 2. Add the contents of the brackets. Let us add the contents. We have 3 plus 2, that is equal to 5. There is no difficulty there. 5 squared minus 3 squared minus 2 squared. Square each number by multiplying it by itself. So let us square each number. 5 squared is equal to 25. 5 multiplied by 5 is equal to 25. 3 squared is equal to 9. 3 multiplied by 3 is equal to 9. And 2 squared is equal to 4. When we say 25 minus 9 minus 4, the result will be 12. There we have it. The second method appears to be a lot simpler than the first. However, the first is much simpler than the second. The problem was designed in such a way that the candidate who is quite familiar with the perfect square should be able to solve it mentally. Now we see that if we go straight ahead and expand the perfect square, we see the difficulty, or not necessarily difficulty, but we see that that process might occupy, consuming a lot more time than if we substitute a is equal to 3 and after determining that b is equal to 2, substitute them into the expression. That seems as if it would actually take a very much shorter time in the examination. However, the expansion of the perfect square is not required in the examination. Candidates who are familiar with that expansion will have no difficulty realizing that a plus b all squared minus a squared minus b squared is equal to 2ab. ab is equal to 6, 2ab is equal to 12. That is done mentally in a few seconds. The examiners did not imagine that any candidate would want to expand the perfect square, but to have it at the tip of the finger. This being the case, the candidate would realize immediately that the expression will simplify to 2ab. The examiners did not imagine that we would want to expand the perfect square, but that we will be sharp in our algebra and have it at the tip of our finger. So we'll be able to solve that in a few seconds. We will then multiply AB by 2 to give 2AB, which necessitates multiplying 6 by 2 and arriving at the answer in less than 5 seconds after reading the problem. The other method should at least consume a few more seconds. Never you forget that mathematicians are the smartest people on the face of the earth. Most candidates are expecting difficulty in the principles required to be applied in solving a problem. A mathematician will set an examination paper with problems that everyone can solve. But if you are not on top of your game, it will be impossible to finish the paper in the time allotted. I have often heard the statement, the exam is easy. Usually we hear that after the multiple choice paper. The exam is easy, but I did not finish. When the examiner may not choose to defeat you with impossible problems, he will defeat you in time. So time is a great factor in an examination, and that might complement the level of difficulty in solving each problem. The volume of a cube which has edges of length 10 centimeters is, a cube may be classified as a rectangular prism or cuboid. Its volume is given by V is equal to length multiplied by width multiplied by height. A cube is special because all of its edges are equal in length. Therefore, the length is equal to the width is equal to the height. All of them are equal. In this particular case, they are equal to 10 centimeters. So our formula will be simplified because all of those dimensions are equal. The volume therefore becomes 10 multiplied by 10 multiplied by 10. V is equal to 1000 centimeters cube. The correct answer is option D. We may also say that the other sides are equal to the length, since all edges are equal. All edges are equal, so we may say that the volume is equal to length multiplied by length multiplied by length. All of the edges are equal in length. There we have it. The volume therefore becomes V is equal to length multiplied by length multiplied by length, which is multiplying 3 occurrences of L together, and that will give us the cube of L, or L cubed. V is equal to 10 to the power of 3, which is equal to 1000 centimeters cubed. In finding the volume of a cube on a speed, it is appropriate to just cube the length of one edge. If you have a cube and you need to find its volume, you will cube the length of one edge, and that's all there is to it. 2,500 millimeters are required to be expressed in meters. Let us take a look at that. The solution of this problem requires a single application of the knowledge of our metric tables. Knowing how many millimeters make a meter is half of the battle. 1000 millimeters will give us 1 meter. This is the beauty of the metric system. All conversion factors are powers of 10. Let us write another relationship, this time with the 2,500 millimeters and its equivalent in meters that we do not know. And we will call that, which we do not know, x. So we have the relationship that is straight out of our metric table, which is 1000 millimeters is equal to 1 meter. And we will write another relationship in order to determine how many meters will be equivalent to 2,500 millimeters. That relationship, we have it right here, 2,500 millimeters, and we do not know its equivalent in meters. That equivalent we call x. In the first expression, the larger number is on the millimeter side. We expect some consistency in the second expression. Therefore, the number on the meter side in that expression will have to be less than the one on the millimeter side. This may be achieved by dividing 2,500 by 1,000. Here we have 1,000 on the millimeter side and 1 on the meter side. Now we have 2,500 on the millimeter side. What do we expect? We expect, as the figure here is smaller than the one over here, the one here will also be smaller than the one that we have here. That will be achieved by dividing 2,500 by 1,000. (2,500) divided by 1,000 is equal to 2.5 meters. Dividing by 1,000 is achieved by reducing a number by 3 places of decimal. The correct answer is option B. The lengths of the sides of a triangle are x, 2x, and 2x centimeters. If its perimeter is 20 centimeters, what is the value of x? The perimeter of any figure is the measurement around it and is found by adding all of its sides. Let us find the perimeter of the triangle by adding all of its sides. So we have x, and that is to be added to 2x, also to be added to another 2x right there. The sum of the sides will give the perimeter that we know to be 20 centimeters. The perimeter is 20 centimeters. Those sides will be added to give 20 centimeters, like so. Add the terms by adding their coefficients. The coefficient of x is 1, and it is clear that the coefficient here is 2 and the coefficient here is 2. So we will add 1 plus 2 plus 2, that is equal to 5, and we have 5x is equal to 20 centimeters. Now we have a simple linear equation that may be solved by dividing both sides by 5. This will cause x to be eliminated from the left hand side, and on the right hand side we will have 20 divided by 5 is equal to 4. We need to eliminate this 5 by transposing to the right hand side. We have 5 multiplied by x here. When we transpose, we will have 20 divided by 5, because we need to do the opposite of the operation on the opposite side. X is equal to 4. The correct answer is option B. A car travels 80 kilometers in 2.5 hours. What is the speed in kilometers per hour? I love this problem. Speed is found by dividing the distance traveled by the time taken. That is how we find speed. The distance is 80 divided by the time taken. I usually experiment with numbers. Dividing by a mixed number is what I enjoy attempting without writing or using a calculator. Division is the reverse of multiplication. Determining the result of 80 divided by 2.5 is the same as saying, what number do we multiply by 2.5 and the result is 80? Twice the number plus half of the number and the result is 80. That is how we need to think. That number is 32. Therefore, 80 divided by 2.5 will result in 32. We know that 2.5 times 32 is actually 2 multiplied by 32 is equal to 64, and a half of 32 is 16. So we say 64 plus 16, and that is equal to 80. Some instructors may suggest that students work from the options, but I strongly discourage that approach. So we will attempt. Sometimes it is good if we can divide or even multiply mentally by a mixed number. It is not difficult to multiply by a mixed number. We have 32 multiplied by 2.5. That means we are talking about 2 times 32, and we are talking about a half of 32. If we can see that process in reverse, developing our numeracy skills, then that is going to be quite commendable. So there we have 32 kilometers per hour. The correct answer is option B. Let us say that the calculation could not have been done mentally or without writing down any information. Let us look at how we could have done it on the next slide. 80 divided by 2.5. We may first convert the mixed number to improper fraction. 2.5, we have the whole number part, we have the numerator, and we have the denominator. How do we do the conversion? Multiply the denominator by the whole number, then add the result to the numerator. So we say 2 multiplied by 2 is equal to 4. That is, we are multiplying the denominator by the whole number. Then we say 4 plus 1. That is, we are adding the result to the numerator, and that is equal to 5. And what will be the result of doing that? The result is the numerator of the improper fraction. So what we have calculated is the numerator of the improper fraction, and the denominator is the same as before. Therefore, 2.5 is equal to 5 over 2. We need to divide 80 by 5 over 2. Dividing by a fraction is the same as multiplying by its inverse. So we reciprocate 5 over 2, we get 2 over 5. The fraction may be reduced by a common factor of 5. 5 into 5 is 1. 5 into 80 is 16. No problem. All we have left is 16 multiplied by 2, and that is equal to 32, which is our correct answer. There we have the problem again. We may make use of the fact that a half is equal to 0.5. 2.5 is therefore 2.5. Let us now divide 80 by 2.5. 80 over 2.5. This is how we used to do it in primary school. When dividing by a decimal fraction, we multiply the divisor by the power of 10 that is required to clear the decimal fraction. For the quotient to remain the same, this will also have to be done in the numerator. So what do we do here? We multiply. In order to eliminate the decimal place that we have here, a single one, we multiply by 10. That will cause a product of 25. We also multiply 80 by 10, and that will give 800. So 800, and that we will divide by 25. 25 is equal to 100 divided by 4. We are taking a look at a little strategy or a little mathemagic that we may apply in dividing by 25. 25 is equal to 100 divided by 4. Therefore, dividing by 25 is the same as multiplying by 4 and dividing by 100. 800 multiplied by 4 is 3,200. Then we will divide 3,200 by 100, and that will result in 32, the same answer that we received initially. The 25 that we have here is actually 100 divided by 4. Therefore, we may multiply by 4 and then divide by 100, and we may arrive at our answer quite easily. A car travels 80 meters in 2.5 hours. What is its speed in kilometers per hour? We may use the fact that common sense is greater than mathematics in figuring out the answer. Common sense is greater than mathematics. That is what we will use, that principle, in figuring out the answer. On the examination of the options, we should be able to determine that the answer is actually 32. First of all, 200 cannot be the result of dividing 80 by 2.5. If we divide 80 by 2.5, we will not get an answer that is greater than 80. It is just there to catch the candidates that will multiply instead. Next, if we divide 80 by 3, mentally we are saying 3 because 3 is close to 2.5. If we multiply 80 by 3, although a fraction will be the result, we are sure that the answer must be greater than 20. 8.25 and 6 will be out of the question. So if we divide 80 by 3, we will get an answer that is greater than 20. Therefore, 8.25 and 6 cannot be correct. The only option that remains will be 32. 32 is the only possible correct answer that we will have. We may even step it up a little bit more and say that 2.5 is between 2 and 4. 80 divided by 2 is 40 and 80 divided by 4 is 20. The result of dividing 80 by 2.5 must therefore be between 40 and 20. Therefore, we are sure that the answer must be 32. The sharp thinker will not take more than a few seconds to make those calculations. That is how long he will take to solve the problem. OAB is the sector of a circle such that angle AOB is equal to 60 degrees and OB is r units long. The area of OAB is what we are trying to determine. A sector is a fraction of a circle. We will use this consideration in determining the area of the sector. The area of a circle is given by pi r squared. Since the sector is a fraction of the area of a circle, we should say that the area of the sector is a fraction of the area of a circle. To find its area, we need to multiply the area of the circle by the fraction that the sector represents. The fraction is equal to the angle associated with this sector, which is 60 degrees, divided by the angle of an entire revolution, which is 360 degrees. The fraction is 60 divided by 360. The angle associated with the sector divided by the angle of an entire revolution. There we have it. We may reduce by a common factor of 60. So 60 into 360, that is 6, and 60 into 60, that is 1. The answer may be written with the fraction as the prefix. So instead of having this 1/6 in this direction, we may write it in the other way, causing the 1/6 to be preceding pi r squared. 1/6 pi r squared is our answer. The correct answer is option D. The problem is not only testing your ability to make the calculation, it is also testing your knowledge of the details of the formula of the area of a circle. If you do not remember that, we have quite a few distractors here. If you are thinking that it is 2 pi r, we have the answer for you. And if you are thinking that it is pi r, we have the answer for you right here. If you are thinking also that it is 2 pi r squared, then we have that right there. eager awaiting your selection. "50 guests each had 2 glasses of champagne. Each glass held 150 milliliters. How many liters of champagne were used?" The fact that all of the answers in the option are related to 15, as we can see, that fact indicates that the examiner did not imagine that we would have any difficulty arriving at the figure. So the figure is not the problem. They are expecting us to do the right thing. So in determining the figure, the correct digits, they are expecting us to do the right thing, which is multiply together all of the numbers in the statement of the problem. So, no difficulty. 50 multiplied by 2 multiplied by 150. When multiplying numbers, we should not do so blindly. Although the order of the numbers really simplifies the process, we may go ahead and multiply 50 by 2. 50 by 2 is 100. Multiplying by 100 is very simple. 150 multiplied by 100 is equal to 15,000. It is obvious that they are testing our knowledge of the conversion factor between milliliters and liters. Since 1000 milliliters make 1 liter, we will divide by 1000. After all, there is no option that suggests multiplication. And of course, we know multiplication is incorrect. So we go straight ahead and divide by the conversion factor, which is 1000. 15,000 divided by 1000 is equal to 15. The correct answer is option C. The area of a rectangle is 53.6 centimeters squared. If the length is multiplied by 4 and the width halved, the area would then be which one of those options? It is expected that we should be able to figure out the answer without knowing what the actual length and width are equal to. We may therefore make use of the fact that the area of a rectangle may be given generally as area is equal to length multiplied by width. Obviously, it is not important for us to know what the length and the width are actually equal to. According to the requirements as laid out in the statement of the problem, let us multiply the length by 4 and take half of the width. So we will have 4L and a half of W. The expression may be reduced by a common factor of 2. 2 into 2 is 1, and 2 into 4 is 2. A is equal to 2 times length multiplied by width. The area turns out to be twice what it used to be. Let us therefore take the original area and multiply it by 2. So by applying the adjustments as laid out in the statement of the problem, it turns out that the area will be twice the area that we had before. We will therefore multiply the area that we had before by 2. 53.6 multiplied by 2 is equal to 107.2. The correct answer is option C. A boy leaves home at 9:15 hours and arrives at school at 10:05 hours. If he travels non-stop at an average speed of 6 kilometers per hour, how many kilometers is his home from school? There are two quick ways that we may use to solve the problem without entirely working it out. The speed is 6 kilometers per hour and the time taken is approximately 1 hour. If the time were actually an hour, the distance would be 6 kilometers, but it is not exactly equal to an hour. It's somewhat different from an hour. Distance is equal to speed multiplied by time. 6 multiplied by 1 is equal to 6. Therefore, if the time were 1 hour, then we will just say 1 multiplied by 6 is equal to 6. We are sure that it is not 6. The time from 9:15 to 10:05 is less than an hour. We will therefore expect the distance traveled to be a little less than 6 kilometers. The correct answer is therefore 5 kilometers. This could have been determined in a few seconds. We are sure that it is not equal to an hour. If it were an hour, then the distance would have turned out to be 6 kilometers. But it is close, the time is close to an hour. So we know that the answer should be close to 6 kilometers. 5 is the one that is close to 6. It is the correct answer. And that could have been determined in a few seconds. The correct answer is option B. On the other hand, seeing that the time is approximately 1 hour, we do not need to consider whether it is more or less. We already know that 1 hour will give 6 kilometers. The correct answer must therefore be close to 6. The correct answer has to be 5 kilometers, which is the only one that is very close to 6 kilometers. If we had another one close to 6 kilometers that is a bit more than 6 kilometers, then we would have had to give serious consideration to the time, whether it is a little bit more or a little bit less. But doesn't matter, because 5 is the only one that is close. It has to be the correct answer. We will attempt to solve the problem on the next slide. Let us find the time taken. We need to subtract the time that he leaves from the time that he arrives. So we need to find the time taken first, in order that we may multiply that time by the speed. There is no crossing of the end of a time cycle, therefore we do not get to midnight, so we have no difficulty. There is no crossing from midnight to another day, so we have no difficulty. There is no crossing of the end of a time cycle. We must just subtract the smaller from the larger. So we are subtracting 9:15 from 10:05, and the result is 50 minutes. The time turns out to be 50 minutes. Some candidates are able to make the calculation in less than half of a second. But let us look at how we may actually work it out. So we can calculate that by just looking at the two times. We'll be able to tell the difference between the two times in our minds. But let us work it out still. Maybe by showing how we may do it actually, then candidates may be able to develop their own mental image of it, and will consequently be able to work it out mentally on their own. So we have, just like a normal subtraction problem, we are subtracting 9:15 from 10:05. We will begin by attempting to subtract 15 minutes from 5 minutes. Because of this impossibility, we go to the hour section and rename 10 hours. The 1 hour taken will be equal to 6 minutes on the minutes side. So we take out 1 from that 10 and we have 9 left, and it will be taken to the minutes column to be 60 minutes. 5 plus 60 is equal to 65. Then 65 minus 15 is equal to 50. So we have right here 5 minutes with 65 minus 15, and that turns out to be 50 minutes. On the hour side, 9 minus 9 is equal to 0. On the next slide, we will demonstrate an awareness of the fact that time is in minutes, but the speed given to us is in kilometer per hour. We have to be aware of that. Although there is no option that is capturing such a mistake, we will still need, if we are going to make our calculation correctly, to consider that the speed is in kilometers per hour and the time given is in seconds. The time that we calculated in minutes, we need to convert it to hours by dividing by 60. We also need to make use of the fact that distance is equal to speed multiplied by time. We need to convert the time that we have in minutes. We need to convert that to hour by dividing by the number of minutes in an hour, which is 60. So 50 minutes divided by 60 minutes. Distance is equal to speed multiplied by time. Divide the time in minutes by 60. The time is in minutes, which is 50. We divide that by 60. So we have 6 is the speed, and the time in hour will turn out to be 50 over 60. Reduce the fraction by a common factor of 10. This may be done by striking off 1 0 from both denominator and numerator. Further, reduce the fraction by a common factor of 6. The correct answer is 5 kilometers and is represented by option B. The marks obtained by 10 students in a test marked out of 25 were 14, 22, 15, 19, 19, 16, 24, 13, 20, or we may say that we have them right there, and finally 19. The range of the marks was, the range is the difference between the largest and smallest items in the data set. Our first duty is to identify the largest and the smallest items in the data set. Good that they are close to each other. We do not have to go too far. We now need to subtract the smallest from the largest, and that will give us the range. 24 minus 13, and that is equal to 11. The range is therefore 11. The correct answer is option A. Sometimes it is not really very difficult, but if we are too hasty, we might not be able to identify the largest and the smallest item in the list, especially that it is not given in numerical order. The table shows the frequency distribution of the marks that a student obtained on a test. How often did the student score 5 marks? How often? We may say, how frequent? This tells us that we need to determine the frequency of 5, and the frequency of 5 is x. We need to determine how often according to the statement of the problem, and how often is how frequent. We need to determine the frequency of 5. and that value is x. One easy way that we may determine that is to make use of the total frequency. However, we do not have the total frequency. If we had the total frequency, all we do is subtract the rest of the frequencies. But we do not have the total frequency. What do we have instead? We, however, have the total of the products of the marks and the frequency. We may use that to find the missing value in that column. Use that to find the missing value in that column. We have the total of the product of the marks and the frequency. We may use the total to find the missing one. All of these will be subtracted from the total, or we may solve an equation in which we say all of these will give a total of 49, like so. We have these added together and the result is 49, not to leave y out. Add all of the values that are accompanying y on the left hand side and we get 39 plus y is equal to 49. Find y by subtracting 39 from both sides. 39 will be eliminated from the left hand side, and on the right hand side 49 minus 39 is equal to 10. Right, so that value of y that we have there is 10. Y is equal to 10, and I have highlighted the entire row of the table in order that we may make more sense of the information there. 10 is a product of 5 and its frequency. So 10 is equal to 5 times x. X is equal to 2. It's as easy as that. X may be found by dividing both sides by 5. 5 will be eliminated from the left hand side, and on the right hand side 10 divided by 5 is equal to 2. X is equal to 2. The correct answer is option A. Could not have found the value of x directly because of the presence of a blank cell in the same row. Also, we did not have the total of the frequencies from which we could take all of the others. So we have taken the necessary steps by finding the value of y first. Then we have found the value of x. The bar chart shows the number of boys with a given number of books. The total number of books is, the graph is telling us the number of boys that have a particular number of books. If 8 boys are associated with 5 books, this means that each of the 8 boys has 5 books, making a total of 8 multiplied by 5, which is equal to 40 books. Let us write down the products associated with each bar. The first bar, 1, has a height of 5. 5 boys each has 1 book. 4 boys each has 2 books. And we have 7 boys each has 3 books. Finally, 5 boys each has 4 books. Let us now calculate the products. So we have 5 multiplied by 1 is 5, 4 times 2, 8, 7 times 3, 21, and so on. 4, times 5 is equal to 20. Finish up by adding the numbers. That's all there is to it. The best way to view this problem is as one involving a variable x, number of books, and associated frequency, number of boys. The total number of books will be the sum of the products of f and x. That is, if you are taking a theoretically statistical approach. It is customary for us to complete the table, then make the calculations. That is, put in all the values of f, then put in all the values of x, then make the calculations. But on this occasion, we will calculate the values of fx while completing the table. So there's your table, and we have x, we have f, which is the number of boys, and we have fx. So there we have x is equal to 1, f is equal to 5, and fx is equal to 5. X is 2, f is 4, and fx is equal to 8. And what do we have there? X is equal to 3, f 7, and fx is equal to 21. X is equal to 4, f is equal to 5, and fx is equal to 20. We do not need the mean, so we will not divide the sum of fx by the sum of f. All we need is the total number of books. This is equal to the sum of fx, and that is equal to 54, and the correct answer is option D. The length of 30 cabbage leaves were measured to the nearest centimeter, and the information grouped as shown in the table. The class boundaries are... Students who are familiar with boundaries and their calculations will not even take a second look at the problem before selecting D as the correct answer. Why? They know that boundaries are usually the averages of two consecutive integers. Each answer should therefore be followed by 0.5. The only option that has this is D. So because we have the boundaries are calculated by taking the average of two consecutive integers, we will have something 0.5 always for the answers, especially in this particular case. Therefore, the correct answer should be the option that has like 9.5, 14.5, etc. Only option D has those. It is the correct answer. A boundary is the common point between two entities. In statistics, it is a common point between two classes. The first class ends at 14 and the second begins at 15. What is the most appropriate number that may be common to both classes that will mark where the first ends and the second begins? And our calculation says 14 plus 15 divided by 2. The average of the two. Taking the average, we get 14.5 is a common point between 14 and 15. That makes a lot of sense even without actually working it out. What do we do next? We have 19 plus 20 divided by 2. the next boundary will be the average of the upper limit of the second class and the lower limit of the third class. Two of the boundaries are enough. There is no other option apart from D that has those values. It is therefore correct. However, we will take a look at some more statistics on the next slide. I am sure that we can already see that there is a pattern that we may use to write down the other boundaries. But it is not good to come to a conclusion about a sequence by using only two terms. So we do not say that it has to be this, although we have no danger in making such an assumption, because if we look at what we have here, look at the lower limits. 10, 15, 20, 25. Those are going up by 5. 14, 19, 24, 29 for the upper limits. They are also going up by 5. We imagine that the boundaries will go up by 5 also. But let us put in a third term in that sequence and arrive at our conclusion in a more acceptable way. Taking the average of those two, let us find the next boundary by calculating the average of the upper limit of the third class and the lower limit of the fourth class. 24 plus 25 divided by 2, the average of the upper limit of the third class and the lower limit of the fourth class. The pattern is clear. The difference between consecutive boundaries is 5 units. The upper boundary of the last class may be found by adding 5 to 24.5, and the lower boundary of the first class may be found by subtracting 5 from 4.5. So there we have 14.5 minus 5 is equal to 9.5, and 24.5 plus 5 is equal to 29.5. The sequence is by 5, so the one that is before this has to be 5 units less. The one after this one has to be 5 units more. The numbers on which the classes are defined are called limits. The smaller values are the lower class limits, and the larger ones are the upper class limits. Lower class limits, LCL. Upper class limits, UCL. And those are the class limits. The lower limits are there, the smaller numbers, and the upper limits are there, the larger numbers. The common number between two classes is called a boundary. We calculated the boundaries on the previous slides. The upper boundary of a particular class is the lower boundary of the succeeding class, and the lower boundary of a particular class is the upper boundary of the previous class. A class has two boundaries. The smaller number is called the lower class boundary, LCL, and the larger number is called the upper class boundary, UCB. Lower class boundaries are on the left, they are the smaller numbers. Upper class boundaries are on the right, they are the larger numbers. Another statistical parameter that has to do with the class that we may find very useful is the width of the class interval, called the class width. Some may attempt to calculate it by using the class limits. It is, however, calculated by making use of the class boundaries. So instead of using the class limits, we use the class boundaries in determining the width of the class interval. The width of the class interval is equal to the difference between the two classes. So it is the difference between the two class boundaries and not the difference between the two class limits. Take any class and the width of the class interval will be the difference between those boundaries. One might ask, why not define the class on the boundaries since they have so many applications? Let's say that we are measuring small organisms to the nearest millimeter. Not every measurement will be an exact number of millimeters. Yet still, the additional fractions are not easily determined. Each value will therefore have to be rounded to the nearest millimeter. Each limit will therefore have to be a whole number of millimeters. The same is not true for the boundaries. Therefore, the classes are not defined on the boundaries. So the classes are not defined on them, that is, not defined on the boundaries, because the class limits need to be a whole number of millimeters in this particular case, because we are taking measurements to the nearest millimeter. So in this particular case, the boundaries will have to be to a whole number of millimeters. Therefore, the limits on this occasion will have to be to a whole number of millimeters. Boundaries are used in organizing histograms and cumulative frequency curves, and the width of the class interval is used in calculation of the mode and median. So we are just giving some more information. Right. Those are not necessarily used, like the width of the class interval, to determine the mode and the median, not at the CSEC level, but we are saying that they have their application in future work in mathematics. The pie chart shows the preference of drinks of a group of students. If 12 students prefer chocolate, then the total number of students is. The problem may be solved mentally by first considering that the angle associated with chocolate is supplementary to 120 degrees. It is therefore 60 degrees. There are 6 occurrences of 60 degrees in 360 degrees. Chocolate is associated with 12 students. Therefore, the total number of students must be 6 multiplied by 12. That is equal to 72. So let us see if we may take a little track at it again. We have the angle on a straight line. A part of it is 120. We know that the angles on a straight line should give 180 when we add them. Therefore, the angle associated with chocolate is 60 degrees. Of the total, 60 degrees will be 1/6. Or we may say that we have 6 angles of 60 degrees in the entire pie, because in this 60 degrees we have 12. Therefore, we need to have 6 times 12 in the entire pie, and that is equal to 72. The correct answer is option B. On the next slide, we will take the approach of a candidate that is not prepared to just take a look at the problem and figure out the answer. So, what I'm trying to do for the most part is, if we can take a look at the problem and figure out the answer, show how that may be done, and we will also work it out and show that we can determine that. In order to solve this problem, we need to take the 12 students that prefer chocolate and associate that with a particular angle in order that we may find the number of students associated with the entire pie. That may seem to be a bit of a mouthful, but in order to find the total number of students, we know the angle associated with the total number of students already. It is the entire pie, 360 degrees. We need an angle here to be associated with the 12 that we have. If we have an angle associated with the 12 students, then we can tell the number of students in the entire pi, because we already know that the angle of the entire pi is 360 degrees. The angle associated with chocolate is on a straight line with 120 degrees. Angles on a straight line add to give 180 degrees. The remainder is the angle associated with chocolate, which is 60 degrees. Angles on a straight line 180. This one is 120. The rest is 60 degrees. From here, the answer may be determined mentally. However, we will use ratios in solving it by considering that 12 students are associated with an angle of 60 degrees, and that the total number of students that we do not know, we are going to call that x, is associated with 360 degrees. So 12 students are associated with 60 degrees. The one that we do not know is the total number of students, and we know that that is associated with 360 degrees. Instead of converting the ratios to fractions, we may see that 360 degrees is 6 times 60. Just take a look at this. 60, 360. This one is 6 times this. So this must be 6 times this. Therefore, x must be 6 times 12 in order that the correct proportions are maintained. The correct answer is option B. So we see the relationship here. This one is 6 times this. For the proportions to be the same, this has to be 6 times this. 6 times 12, 72. The correct answer is option B. A boy throws a die twice. What is the probability that he will get a 3 followed by an even number? Finding the probability of getting a 3 followed by an even number is the same as finding the probability of getting a 3 and an even number. The probability and is found by multiplication. Our first duty is to find the probability of receiving a 3, then the probability of receiving an even number. We need to multiply those two together. The probability that an event will occur is equal to the total number of events that will give a favorable outcome divided by the total number of equiprobable events. So the probability that this will occur is equal to the number that will give the required result divided by the total number. To find the probability of receiving a 3, there is only one 3 and a die. So the probability of receiving a 3 will be, since there is only one 3, will be 1. So the number of events that will give us a favorable outcome is 1, because we have 1 3. We will divide that 1 by the total number of events that we have. So the total number of events that will give a favorable outcome is 1. We will divide this by the total number of equiprobable events. This is equal to 6, since the die has 6 faces with 1 number each. So 1 out of 6, or 1/6. So we have 1 3, and we are required to find the probability of receiving a 3. 1 divided by the total number of events, and each is represented by the numbers that we have on the face of the die. That will be multiplied, that is the probability that we have just determined, will be multiplied by the probability of receiving an even number. there are 3 even numbers on the die, the total of events that will give a favorable outcome. The total number of events that will give a favorable outcome is therefore 3, because we have 3 even numbers on the die. And we will divide that by 6, the total number of equal probable events. The first one is 1/6, 1, 3 out of 6. 3 even numbers out of 6. There we have our fractions. The fraction may be reduced by a common factor of 3. 3 into 6 is 2. 3 into 3 is 1. The result is 1 multiplied by 1, 1 over 6 multiplied by 2, 12. The correct answer is option A. Instead of going all the way, reducing the fractions, we could have made use of the fact that 3 out of 6 is a half and multiply 1/6 by a half. So we could have done that earlier on instead of having these fractions that we have to reduce eventually.